Quick review of substitution. You're going to take either equation and isolate a non-squared variable. Then we're going to substitute that equation into the other equation. We're going to solve it. And then we use whatever we had in step 1 to find the second coordinate of the answer. So pick an equation, equation 1 or equation 2? I heard 1 first. We want to isolate a non-squared variable. So would you like to get y by itself or x by itself? Y. Well, excellent. It's already variable by itself. So then we're going to take the other equation. And I'm going to take y out. And what am I going to put in its place? Okay, so x squared goes in. Right-hand side stays exactly the same. Why? What kind of equation is it? How many ways are there to solve a quadratic?
4.
Which way would you like to use?
Square root.
Okay, let's square root it. Let's do it.
I'm down.
Oh yeah, you're telling me. I'm just writing down.
First well, there's an x squared there, so you're not square root, right?
Mm-mm.
I don't think we did the square root.
I don't think so either, but it would be fun.
Complete the square.
Okay.
Yeah, but don't press hard. Don't press hard. Don't press hard.
And then you put the 2 brackets with the 1.
Are we factoring or are we completing the square?
Always get
Complete square. Wait, which one are you looking at?
Yeah, that's what I meant. Then you put like
Yeah, I did do some of that.
quarter.
Plus 1.
No,
Wait, no.
plus quarter.
No.
1 quarter.
Oh, yeah,
Yeah.
quarter.
And then minus a quarter. And then like you
I was really fast.
Then you factor the first
root it. So you got x minus negative a half. And then you do minus 1 and 3/4. Sorry, minus 2. 2 and 1/4.
Negative 2. Oh, 9 quarters.
Just a heads up, I would have factored, but this is good.
And then it's 1/2. And oh.
We haven't solved it. We don't need the vertex.
You have to solve
What do we?
We're solving.
Find?
We're solving.
Solve what? Oh,
origin of x.
Wow, we should have really learned this in Unit 3. Yeah, but we did this method of solving.
What are you trying to find?
We're trying to solve for x.
Okay.
Can't square root yet. Oh yeah, I totally would too, but let's continue.
Add 9 quarters.
Okay.
And to the other side too.
And you write this in pencil now.
And then you well, no,
Oh, plus 7.
and then you do the
X minus 1/2 equals plus or minus. Do we know what that is?
and then you do
Plus 1.
yeah. Which has like 2 and 1 half. No, 1. Right? Negative 1.
We could have gotten that in one step with factoring, but hey, that was some good math. But we're not done. That's just the x coordinates. What do we still need to find? So we go all the way back up to the first step, and we're going to put in each of those values.
1 and 4.
And then we just need to write the answer as coordinate pairs. because you didn't pick factoring.
To be fair, I was the one that said not pick. I figured it out as soon as we got to the second part there. I'm like, wait, we should have done that.
Yeah, but that was some good review. I like that.
It's not okay.
Elimination. We're going to arrange the equations so that the variables are in the same order. We're going to multiply as needed to eliminate the non-squared variable. Then we're going to add the equations to eliminate the other non-squared variable. Then we'll solve the equation. Then we'll go back to step 4 and put it in. So because there's a quadratic, I'm going to set it up a little bit different than you saw last semester. I'm going to start with the first equation, and I'm going to put x squared. And then I'm going to add a 0x and a 0 as a constant. And the only reason I'm doing that is because I want to line up the next equation in the same way. Does the second equation have any x squareds? So I'm going to put a 0x squared, and then the x, and then the 2. You don't have to put the zeros. You just have to make sure you're adding x squareds with x squareds, x's with x's, constants as constants. So I find the zeros just help lines it up. What we want to do is these to be the same coefficient, the opposite sign. So one to be positive, one to be negative. Are they currently opposite signs? So we have to multiply. There's lots of choices here. We could multiply the first one by -1 and the second one by 1. We could multiply the first one by 1 and the second by -1. We could choose 2 and -2. We could choose 3 and -3. We could choose a quarter and -a quarter. We could multiply by anything we want as long as the y's are the same value in the opposite sign. What would you like to choose? -1 and 1. Note the notation there. You might not have seen that last semester. This means I'm about to multiply by -1.
I thought that was squiggly.
Kind of.
No, that's double. Mine too is equal. So like, is it equal? We don't know. Oh yeah, no, I thought it was a squiggle that meant like it was approximate.
That's a double when it's an equal sign. 1 just means I'm about to multiply by.
Right.
So y times -1,
Got that.
x squared times -1, 0 times -y. So the zeros aren't going to change. And the second one I'm leaving alone. Then what we do is we add them vertically. So -y plus y. 0, and that's the point. That's, ooh, my purple pen's running out. That's why we wanted to eliminate them, was to get rid of the y. -x squared plus 0x squared. 0x plus 1x. And 0 plus 2. Again, you don't have to use what I call the zero placements. The problem is if you just stack them, you're going to want to combine an x squared and an x. And you can't combine those together. So I like putting the zeros just so everything's stacked up. Why? What kind of equation is it?
Quadratic.
How many ways are there to solve a quadratic? How about we pick factoring this time? Would you like the x squared to be positive? How can we turn it positive? Multiply everything by a negative. Product of -2, sum of -1. Offer of -2 and +1.
Wait, should we have 2 negatives? Oh. Yeah, never mind.
Okay, split and solve.
And -1.
Oh, and look. Right? Should have the exact same answer or we've done something wrong. But are we done? And your brain is going to want to stop there because we've done so much work solving quadratics, you think now x is the end of the answer. What do we still need to find? So we go back to the original. It doesn't matter whether we go back to the quadratic or back to the linear. Let's go back to the linear since we did the quadratic last time. So I'm going to put in 2 and then -1. 2 plus 2.
4.
-1 plus 2. And then we just state them as coordinate pairs. So 2 and 4, -1 and 1. I'm going to box this part in the first and this part in the second, just to show this was a choice. Okay, we chose a method. You could have done them both factoring. You could have done completing the square. We just chose different methods for each one. Does that kind of put elimination substitution back in your head?
Yeah, definitely like
Let's step it up. Let's make the numbers bigger. If the question specifies a method, you have to use that method. It doesn't matter if you get the right answer using a different method. We're testing, do you know substitution? If the question doesn't say, then it's completely up to you. So this one says substitution, we're going to use substitution. Step 1, pick an equation. Equation 1 or equation 2? Pick a variable, x or y. Which one would you like to get by itself? Okay, so we're going to start by taking the 18x over. And then we're going to divide by. That's why we picked y. Then we're going to go to the other equation. We're going to take y out. We're going to put 9x plus 4 in its place. Just be careful with the negative in front of the y. So keeping the 4x squared, keeping the 5x, keeping the negative. When we substitute, we're going to bracket. 9x plus 4 goes in. So everything else stayed the same except the y, and I just put what y was equal to in its place. Oh, this negative 4? Totally my fault. Lost it. Thank you. It's okay, we found him. It's all good. Now we're just going to simplify, so get rid of the brackets. So I've got a 4x squared, a 5x, the negative 4 I forgot last time. And what do we do with that negative in front of the brackets? Just distribute, so negative times 9x, and then negative times 4. Simplify, how many x squareds do we have? How many x's do we have? The constants. How many ways do we solve the question? I'm going to factor. First, 4, 4, and 8. What do you see? Yeah, a common factor of 4. Yeah, I will in the next step. You're just ahead of me. I'm just a factoring fan. Can I go back up? I'm going to divide by the 4 just to get rid of it because we don't need it. Product of negative 2, sum of negative 1. Offer of plus 1 minus 2. It's the same question as last time. What do we do once we factor? Split. Again, this is where your brain is going to want to stop because we've done so many of these questions that have stopped here, but this is a system, so we're looking for intersection points. What do we still need to find? So I'm just going to grab our expression we had up there for y. I could use the quadratic. It's just going to be more work, so I'm choosing to use the linear. Nine times negative 1, and then plus 4. Negative 5 with a question mark. Negative 5. And again, I like to write the coordinate right away just so we don't lose track that it is a point we're looking for. 9 times 2. plus 4, 22. So the second coordinate is 222. Why do I feel like pizza right now? The method is no different from last year. The only thing that's new is just the fact one of the equations is a quadratic. Number 2. Wow. Wow.
This is why I like elimination better.
Here's our first quadratic system. Does it specify a method? Pick an equation, pick a variable. Here's a hint, look for coefficients of 1. If there's a coefficient of 1, it's going to be less work than if there isn't. Would you like to pick a particular equation? I would pick the first one too, and what would you like to isolate? The y, so I'm just going to bring the y to the right, or sorry, to the left. What do we do with that? So we take the y out, and what's going to go in its place? The negative 2x plus 18. Just make sure you're using brackets. So 0 equals 2x squared minus 2, and then your open bracket, minus 2x squared plus 18, close bracket, plus 12. Okay, so y came out, negative 2x squared plus 18 went in. Before factoring, we probably want to simplify. So I've got 2x squared, negative 2 times negative 2x squared, negative 2 times 18, bless you. That was a lot of answers. And then still that plus 12 hanging around at the end.
6x squared minus 24.
Pick a method. Okay, is there a common factor? What can we do with the 6? Divide by to get rid of it. What kind of factoring? Two terms, say it again, louder. High five, difference of squares. If you wanted to use square root method at that point, you could too. Offer of 2 and negative 2. Split. Yeah, so just don't lose track. We're not done. Go back and find your equation for y. Bed mass, what do we do first? Okay, so negative 2 squared is? 4. Oop, 10 or minus 10. Confirm. It's the same thing. Why is it the same thing? Because parabolas are kind of, what's the vocabulary word? Something, axis of symmetry. They're symmetric. So you'll get a lot of the points that are like that. No, it just means that the vertex is in the middle, and so you're at negative 2 and 2. Show me your thumb so far on substitution. Getting it, kind of getting it, not getting it. It's good. Let's do one of elimination. first thing we need to do is we need to line them up. So I want the y usually on the left, everything else on the other side. So what do we do with this first equation? I feel like the y is on the wrong side too, because I said y on the left, everything else on the right. And what I'm going to do now is add in the x squared. How many x squareds do we have? 0, so I'm just doing that so I can line it up with the other equation in a second. Take a look at the second equation. Is it in the right form? Does everything line up? Is it the right order? So I'm just going to put it underneath, and I'm just changing colors so you can see what the second equation is. Again, you don't have to put this 0x squared, but you just need to realize later you can't add an x squared to an x. So x squareds have to be added to x squareds. We're looking for a set of coefficients that's the same value, opposite sign. So check out the y's, the x squareds, the x's. Are there any coefficients right now that are the same but opposite sign? That means we need to do some work. What do you want to do? Yeah, so it's usually easiest to get the y's by itself, or y's the same, but you can get the x's. It's completely up to you. So if we want the y's to be the same, we've got lots of choices. What would you like to multiply by? I heard 1 and -1, so first one by 1. That means the second one by -1. Is that our only choice? No, I could have switched those. I could have used any numbers as long as they were the same. And again, that symbol just means I'm about to multiply by something. So first equation stays exactly the same. What happens to the second equation? To what? Then we just add them vertically. The arrow is typically for left people because then we can see how it's going. Y minus y? 0x squared minus 8x squared. 8x minus 6x plus 3.
I'm going to go, I kind of jumped ahead of it, so I multiplied the top by -1.
And that's fine. You'll get the same answers in the end.
Yeah, I know.
Pick a method. Can we quad formula? We haven't quad formulated anything yet. Can we? I love quad formula. Negative b plus or minus. Okay, so what is b squared? Which would be 4. And what is a times c? And then on the bottom?
2 times
And what is 2 times a? That was a lot of answers in a short time. Are you okay there with the steps that I skipped? Okay, underneath the root first. 4 times 24. Do 20 times 4. And then 4 times 4, and then add them together. And then we would have had 4, so 4 plus 96. Ooh, and that never makes us happy. How come? Perfect square.
I think we just leave
12 divided by 6 is 3 over 4.
confirm? Make sure, because I'm not telling you if you made a mistake. Are we done? What do we do? Okay, do you want to use the linear or do you want to use the quadratic? Let's use the linear. Where do we have it? Up here. No, no, it's okay, it's okay, it's okay. They're good fractions.
Brain's too small.
No, you can do this. What's under the 8 that we don't see? Okay, so top times top, bottom times bottom. 24 on the top, 4 on the bottom. Oh, see, look how pretty that is.
I don't know what that is.
Oh, 11.
Wait, I have a question.
Yes. Oh, we could have. We just would have had to then square that fraction and then multiply it, so the linear is just less work, that's all. We could have. We could have used the quadratic. So, boop, boop, boop.
It's -8.
Negative
4?
4.
Oh.
That's 5. And that's 9. No, 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 no. It's 1.
That's the hardest they're going to get.
Will this be on the final test?
Yes. And we're not going to do the word problem just like last time because those are out of the curriculum, so we don't need to do them.
You're not in the curriculum? Why?
We took them out.
Well, I already know that.
In applied.